Okay, let's consider this topic variation. So, what is variation? Simple. Variation is used to describe relationship. Is used to describe relationship between quantities, two or more quantities. Now we have about four different types of variation we're going to consider, but for this first part of this video, we're going to consider just two types, right? Direct variation and indirect, or sometimes called inverse variation. So what's direct variation? Remember, we said that variation is used to uh, describe relationship. I like this word relationship in variation because understanding what relationship means is going to help you to clearly see what's going on in variation. So in direct variation, we're saying that the relationship between two quantities under consideration now is mutual, right? They are always going in the same direction. Look at what I mean. Let's say we have a quantity x and we have another quantity y. If they are directly proportional, please, another word for this variation is proportion, right? So if they're directly proportional, what we're saying is that as the value of x is going up, the value of y is going up at the same time, equal amounts. So we have two keywords. The first keyword there is what? Relationship. So it shows the relationship between two quantities. And then another keyword is at the same rate. What I mean simply is that in direct variation, two quantities under consideration, which is in this case x and y, are going in the same direction at equal rates. That means if the value of x is increasing, the value of y will also increase. But now they're not increasing carelessly, they're increasing at the same rate, equal amounts. So that means if x increase by 2, that means if you multiply x by 2, y will also be multiplied by 2. And similarly, if x decrease, y will also what? Decrease. So this is what direct variation is all about, at the same rate. Real life example, let's say the price to be paid for a particular commodity will be directly proportional or will vary directly as the amount of the commodity. What do I mean? Let's say one biscuit costs 50 naira, right? So the quantity here now is one biscuit, while the cost is what? 50 naira. You discover that as the biscuits increase to 5, as the quantity of the biscuits increase, the price will also increase to 50. So this is what I mean by direct variation. Two quantities increasing by equal amount or decreasing by equal amount. So if the quantity reduced to 1, the price reduced from 250 back to 50 naira. Why indirect is just the opposite, right? So in indirect variation, quantity is x and y. As s is increasing, y will be decreasing by the same rate also. So it is the same rate. That's another keyword, the same rate. And if x is decreasing, y will be increasing. So they are not going the same direction, they're always going opposite. That's the meaning of inverse, right? Because if you can remember, 5/1, the inverse of 5/1 is what? 1/5. So they're not going the same direction. So that's what indirect variation is. So but let's state this variation mathematically. If s varies directly as y, how we write it is this. Variation has a symbol. So that symbol there is the symbol of variation. So this is how we write it, that s varies directly as y. Alright, so to write this is the expression. To put it as an equation, this will imply x is equal to, now you see I'm removing this variation symbol, I'm changing it equal to, I'll now introduce a constant k times the y. Now what is this k? This k is what we call the constant, right? Let me just write it out. This is the symbol of variation, right? Y, k is what? The constant of variation. So it's a constant of variation, or the constant of proportionality. Where is k coming from? You see that since these two values, x and y in this case, will either increase or decrease by the same amount, since they are directly proportional to each other, there must be a number, a certain value that is doing the increments or the decrements as the case may be. So that certain value by which two of them must either increase or decrease is called the constant of variation. So, and it's not a must use k. You can use any algebraic term. You can use a, b, c, d, e, f, but traditionally we just love to use k. It's not as if it's a must do. So that's how to draw the equation for what's a direct variation. Now, one thing you need to know is that if you're solving a question on direct variation, you must first of all find that constant, because we can't find the value of x or y, as the case may be, if we have not yet found the constant. So please, that is a simple tip you need to remember. The constant is first found before we solve any question, right? And then what of inverse? If s varies inversely as y now, remember inverse of a number is 1 over that number, so we write it as 1 over y. This is for inverse, meaning that they are not going the same direction. If s is increasing, y will be decreasing and vice versa. So in an equation form, we have that x is equal to what? Remember, you just multiply by the constant. K times 1 over y will now be k over y. So this is it for inverse variation. And please note, x varies as y is different from y varies as x. Right? In y varies as s, we're now going to now have y is equal to kx. And the same thing here. If y varies inversely as x, it will be y is 1 over s, which will now be y equal to k over x. So this is how to do it. Okay, we're going to solve questions now with what we have learned. So look at this question. Let's say we have s varies inversely as y, and when x is equal to 2, y is equal to 4. So we should find y when x is equal to 3. Now this is a question. You see that the equation says that s varies inversely, so we're going to write the equation. Equation would be x varies inversely. Remember, inversely is 1 over y. So s varies inversely as 1 over y. We'll now write the equation. This implies that x is equal to the constant times 1 over y, which is k over y. Now, another secret you need to know is that the first values of x and y you're given is for you to find the constant. Remember, you must always find the constant. So, we're just going to say when x is equal to 2, y is equal to 4 from the question. So, we're going to substitute the values here. So from this equation now, we now have x, which is 2, equal to the constant over y is what? 4. So like this, we can find the constant. You now have that k is equal to 4 times 2. So that k is equal to 8. Now, this is our constant. It's just that it was not asked in this question, but most often than not, they will ask you to find the equation connecting x and y. The equation connecting x and y is this equation, only that you now have to replace the value of k with what you found as k. So our k is 8. So the equation connecting this x and y quantities will be x equal to 8 over what? Y. So this is our equation connecting. Now when you find this equation connecting x and y, you can now use it to solve the question that was asked. So you see the question asked in this one is that find y when x is equal to 3. So we're looking for the value of y when x is equal to 3. All we need to do is just substitute the value of x as 3. So from there we now have 3 is equal to 8 over y. You cross multiply, we have that 3y is equal to what? 8. So we just divide both sides by the coefficient of y to get y. So you see that y is equal to 8 over 3. Or we can write it as a mixed number since it's an improper fraction. So 3 into 8 will be 2 because 3 times 2 is 6. So 2 remainder 2 all over 3. So when x is 3, y is going to be 2 whole number 2 over 3. Again, I want to leave you with a secret. So the secret is by understanding what variation is. So let's solve this question in another way. So you see that they say that x was 2 initially when y is 4, right? They now say that x is now 3. And remember, it is inverse variation we are solving. So look at what we're going to say. We're looking for x now. We're looking for y. So understanding this topic is going to help you to solve these questions faster, especially these ones that don't have square root or raised to power 2 or cube root. If you just plain, you can solve faster. What I'm going to say is, okay, what is inverse variation? We say that in inverse variation, if one quantity increase, the other one is going to decrease since they're not going in the same direction. So we're going to say, you see that 2 is, x is increasing from 2 to what? To 3. So x is increasing. That means if x is increasing, y must decrease. So y must be decreasing, right? Since that's the law of inverse variation. So I'm going to ask myself, by what factor did 2 increase to 3? How to do that? Just always divide the big one over the small one. So we have 3 over 2. That's how 2 increased to 3. Alright, so I'm now going to use this factor of increment to reduce 4 because they are going to either increase or decrease by the same rate. So I'm now going to have 4. Since 4 will reduce, I will divide this. I'll have 4 divided by 3 over 2, which will now be 4 times 2 over 3. If you change the division to multiplication, you flip the fraction. So which will be what? 8 over 3. You see what we had there before? 8 over 3, which is 2 whole number 2 over 3. So that's how to solve these questions faster. Alright, but if not, you can also use the other formula to solve. So let's see another question. So we have a question. The number of students n varies inversely as the number of days d. So let's write the equation. N varies inversely. Since it's inversely, we have 1 over d. Let's write the equation already. So we have n is equal to the constant times 1 over d, which is k over d. Okay, to cut the school field, they say if 15 students, so n is 15 here. So when n is 15, if 15 students will cut the field in 2 days, so you see that d will be 2 days. Alright, so remember I told you the first values is to solve the constant. So let's find the constant. So from this place, we have n is equal to k over d. So n is 15 now, is equal to the constant k over d is 2. So just cross multiply. K will be equal to 15 times 2, which is 30. So our equation connecting this thing would be n equal to 30 over d. We replace the value of k. So n equal to 30 over d is the equation I'm going to use to solve. Now what's the question? The question starts from here. You see this part. They say how many students will cut the field in 5 days? So how many students? We are looking for n. We don't know. The days is what now? 5. So I'm going to say, okay, from the equation, n is equal to 30 over d is what now? 5. So 30 over 5 is simply 6. So 6 students, since n is students. So that's the answer. 6 students will cut the field in 5 days. And it makes sense, right? Since we are saying that in inverse variation, if one is increasing, the other one will decrease. So you see that the number of days increase from 2 days to what? 5 days. So if the number of days increase from 2 to 5, that means the number of students will decrease from 15 to what? 6. Yes, as one is increasing, the other one will be decreasing.